This video is about mineral formation and the ways in which that happens. And I'm really glad you're watching because this concept is on your test. It is about 1/3 of the point value of your test. You won't be writing any essays on this topic, but you will need to be answering several short answer questions about the process of mineral formation. If you recall in class, we did the power thinking activity, and this should be in your notes. The important thing that should definitely be there is this word crystallization. Crystallization is how all minerals form. They either form through the crystallization of molten material or the crystallization of solutions. Let's take a look at each of these 4 ways that minerals form. On this picture, you see crystallization of minerals by evaporation. Long ago, there used to be an ocean where we live. And those oceans have since gone away millions of years ago, and they left behind deposits of minerals such as this gypsum or selenite. They've also left behind halite deposits in our area, and that is because of evaporation. When you have a mineral-rich solution like you see here, an evaporation occurs. You saw samples of this in class when I showed you the evaporation of the sodium solution and the magnesium sulfate solution. This picture shows 3 other ways that minerals form. Let's talk first about molten material. Down at the bottom, you see magma cooling, and magma is simply melted rock. Rocks are made of minerals, so magma is essentially melted minerals. And when the minerals are melted, when they're molten, the atoms tend to find each other. So, for example, this tourmaline formed when the tourmaline atoms in the melted magma found each other and the magma cooled. The tourmaline atoms were all together, and so they crystallized from the magma. The other thing that the magma can do is come to the surface. That can happen in an area here such as just a crack in the ground or even in a volcano. And when magma comes to the surface, it's called lava. When that lava crystallizes, it can form minerals, and that crystallization happens much faster than it does underneath the surface of the earth here in a magma chamber. The other thing the magma does is it warms any groundwater in the area. So imagine there were groundwater in this area right here. The magma that is down here is warming this water. When it warms the water, it encourages the minerals from the surrounding rock to dissolve in this water. So now you have a mineral-rich hot water solution underground. Because it's underground, it is not going to evaporate. It's trapped. There's nowhere for the water vapor to go. So this mineral-rich solution stays liquid and hot as long as this magma continues to heat it. If something happens, and there's plate movement or a variety of other things that might cause this magma to cool, then this water solution is going to cool. When this solution cools, remember it has a lot of minerals in it, this solution cools off and the minerals crystallize in the solution. So the water doesn't go away, but the minerals crystallize in it. Now, if something were to happen and perhaps a crack is to form in the crust, maybe there's a crack here from an earthquake, for example, that might drain this area that has a mineral-rich solution in it, and now perhaps we would have an area that has beautiful crystal formations, but no longer any solution because it drained away in this crack. Eventually, maybe a cave dweller might discover this beautiful room of crystals perfectly formed, similar to that picture in your textbook of the gentleman who found the selenite crystals in that cave in Mexico. This is one of the most interesting ways that minerals can form. This is through a solution, the crystallization of minerals in a solution, but not through evaporation. Thanks for watching, and I hope this helps you on your test.